All right, this is our second type of inequality. These are our and where our or included everything, our and is only going to include what we have in common, so any overlap between our two inequalities. So again, if we have that lovely Venn diagram that I know you see in the humanities all the time, when we're talking about an or inequality, we only care about what's going on in this overlapped region. So anything that they don't share, we don't care about. And what's nice about and inequalities is that we're going to be able to write them as a singular inequality statement rather than having to use the word and. So let's go ahead and graph this first so we can see what's going on graphically. We have x is greater than or equal to -6. So we're going to go ahead and graph a filled in circle on -6, going to the right. Then x is less than or equal to 1, so I'm going to have a filled in circle. I'm going to use a different color. Filled in circle on 1. Less than, I'm going to the left. Notice the only part that they share is from -6 to 1. And so whatever this symbol is the symbol that we're going to use for each of those. So if it had been an open circle, we would use an open circle. And then we're filling in everything in between. So this orange part is my only solution. And so what we're going to do, because we can write this as the space in between, we can actually write them going from our minimum value of -6 all the way to our maximum value and put x in between them. Because x is going to be greater than or equal to our minimum value and less than or equal to our maximum value. So when we have something like this, x is greater than or equal to -6 and x is less than or equal to 1, we can put the x in the middle, and we're just writing both statements. So what I'm going to do here is I'm going to just flip the order of this. So this says x is greater than or equal to -1. If I read that backwards, it says -6 is less than or equal to x. And so notice that I have a less than or equal to and a less than or equal to. So I'm going to put both of those symbols down. My minimum value is -6. My maximum value is 1. So we can write any of these and inequalities as one inequality like this. And so what we're going to be able to do is solve the inequalities all in one shot instead of having to solve two separately, which is pretty cool. So let's take a look at an example of that. So here we have an example of two inequalities written in one. So I have the inequality x plus 4 is less than 9, and then I also have the inequality 2 is less than or equal to x plus 4. So we could solve these separately. We would subtract 4, I get -2 is less than or equal to x. Subtract 4, x is less than 9. So notice that I did the exact same steps on either side. I subtracted 4 for both of these. So because we're doing the exact same steps, and the next example I'm going to show you, we can just do them all in one shot without having to separate out the inequalities. But let's go ahead and graph this. So I'm going to graph this guy first. X is less than 9. So I go to 9. X is less than 9 with an open circle. Now this says -2 is less than all of my other values. So if -2 is less than all or equal to all my other values, then that must mean that all my other values are greater than -2. And so my actual solution here is going to be a closed circle on -2, an open circle on 7, and then I'm filling in everything in between. I could write this as a compound inequality, as one inequality, like this. Again, this is my minimum value, and this is my maximum value. And you see that here. This is my minimum. This is my maximum. None of this is part of my solution set because I don't have that in common with both inequalities. All right, let me show you what this looks like when we solve it within one inequality. So if I have something like this, I'm looking just at this statement, and I'm saying, okay, how am I getting this x by itself? To get x by itself, I'm going to add 13. So I need to add 13 here. I need to add 13 on this inequality and add 13 over on this inequality. So I have a 7x remaining. I bring down my inequality symbols. 8 plus 13 is 21. Negative 27 plus 13, different sign, so I need to take the difference. I get 14, and then I have more negative. I'm going to go ahead and divide everything by 7 because that's my next step to get x by itself. And I end up with x is less than 3, x is greater than negative 2. So this is saying I want everything in between negative 2 and 3. So I'm going to go to negative 2, put an open circle. I'm going to go to 3 and put an open circle, and I want everything between them. You don't have to do, you could do a straight line there too when it's above. All right, let's try one more together. Then I'll have you go back and try 8 and 10. So on number 9, we're going to do the same thing. I need to get x by itself. First, I move my constant term, so I'm going to subtract 1 from either side and on this side. So 3 different spots. So we end up with negative 2 is less than 2/3 x, which is less than 4. Now, we're going to go ahead and get this 2/3, or to get this x by itself, I need to get rid of the 2/3. So we're going to multiply by the reciprocal, multiply by the reciprocal, and multiply by the reciprocal. So we now have x is less than 12 divided by 2. X is greater than negative 6 divided by 2. So we end up with x less than 6 and x greater than negative 3. So we're looking between negative 3 and 6. Everything in between, but because I don't have the or equal to, we're not actually including negative 3 or 6. All right, go ahead and try numbers 8 and 10, and then you're going to do some more practice on Delta Math, and then you can get started on your homework.